Welcome to Math Dive in 5, Grade 3. My name is Daryl Frost.
I'm Barbara Knox.
This is focusing on Unit 10, Multiplication and Division, Problem Solving. So in just a moment, you're going to pause the video. You're going to complete the task on the next slide on your own or with a team or a grade level partner. Solve the problem using 3 different strategies that you would anticipate that your students might use. As you are working through the task, reflect on the 3 questions you see at the bottom of the slide.
We'll see you back in a few minutes.
So let's take a look here at the progression with BEST. You see the trajectory is from 1st to 4th grade. Obviously, this is 3rd grade here. And you see, I'm just going to very quickly highlight this 2nd grade benchmark, AR32, focused on repeated addition, which naturally connects to, and in 3rd grade, understanding the multiplication and division. So here, and then of course that moves into the quick recall of basic facts, and that's where procedural fluency or exactly, or automaticity occurs. But we're going to focus here on, in this scope, on procedural reliability. And remember, it's loosely defined by the BEST benchmarks as a strategy that a student can essentially rely on to solve a problem that involves multiplication. So you've already solved the problem with 3 different strategies here. And they're one-step multiplication and division problems, but I'm curious as to how many of you considered a tape diagram as a strategy to solve, because all those strategies there are strategies that can be reliable to a 3rd grader in solving multiplication and division problems. So we're going to take a look at tape diagrams.
And Daryl, we need to take them back to making a tape diagram concretely so that they can make sense of it when they draw it pictorially.
Yes, and if you think about, if you say like a bar is 4 units, that can be very abstract.
Right.
Where's the 4 units? I can't count anything.
Right.
So we're going to take a deep dive into that. Okay, so now let's take a look at this Susan and Jenny problem about oranges. And you've probably already noticed that this is a multiplicative comparison problem. And this has,
that used to be in 4th grade.
It used to be in 4th grade, but you know what, Barbara? I looked in the benchmarks, and you validated it. We looked in the benchmark books, and there's nothing specifically stated about multiplicative comparisons either in 3rd or 4th grade.
Correct.
But we made an instructional decision as a K-5 team to err on the side of caution and teach this interpretation, because we do have resources in it in STEM Scope, so they're prepared.
Yes.
So that's where we are.
So we're now teaching all interpretations of multiplication in 3rd grade.
Yes. And we're focusing here on a tape diagram. Now, I don't know what you did. You could have solved this in a variety of different ways, but we're going to focus here on this.
So here's my tape diagram, right? I've drawn this model. Here's Susan's 3, and Jenny has 3 times as many. So each one of those boxes has 3, but that's pretty abstract, right?
It's very abstract. And so we have to think about CRA.
Right. We want to take it back to
the concrete. How can I make this concrete
model?
There you go. I used square tiles. I started that I knew that, what did I know here? Susan bought 3 oranges for her family.
So here is Susan's 3 oranges right there.
There we go. And it says that Jenny bought 3 times as many oranges as Susan did.
So I have to be able to see 1 times as many, right?
Right.
There's one group of what Susan had.
And I want to use that language with that concrete model. And I could connect that. What multiplication equation would fit with just that piece?
3 times 1.
3 times 1 is
or
3.
1 group of 3.
Or 1 group of 3, right? So now they have, right now they got the same amount.
They do.
So
And then I could also do a second group, right? So
there you
here's
go.
another group of three. So now I have two groups of three.
So we're seeing how that's 3 times 2 right now. Jenny has 6 oranges,
Or two groups of
or,
Susan's oranges,
or 2
right?
groups of Susan's oranges.
Right.
And now we have Jenny has 3 times as many as
So I
Susan.
need another group.
I need another group of Susan's
And
oranges.
here is my third times as many, right? So now I have 1 times as many, 2 times as many, 3 times as many. And I can see each of those groups of 3 within my model.
And then I could go to something more representational, which is that's a little more on the abstract idea because it is, but I see, you can now see, oh, I see that there's 3. Well, I could just draw a box now, a rectangle, and say
Right.
Susan's got 3.
I might even, if I have this on the whiteboard, I might just draw my boxes right around those 3 concrete tools to
That's
help
true.
make that
Yeah,
connection between
there you
the two.
go. And so they would see, oh, I don't always have to use this, but this helps the understanding of this interpretation.
Right, and we've kind of answered that first question, right, where we're going to make connections.
And then in the abstract, write the equation that represents how many oranges Jenny's family received. Well, what would you write?
I'm going to do 3 groups of 3.
Sure, and your model says that, right?
It
It's 3
does.
groups of Susan's oranges, so Jenny must have 9 oranges.
That's right.
Challenges and misconceptions. What would be the big challenge here with this particular interpretation of?
I think that some students might take and look at this model and think that the answer is 12 because they see Susan's and Jenny's together. And I could have a question where the answer would be 12, right?
Sure,
I have to really pay attention to what question is asked.
I bet on a multiple choice assessment on this particular interpretation, an answer choice would be 12. So I have to really think about, I've got to ask questions for them to connect and labeling.
So in order for the answer to be 12, what would the question have to be?
What would be the total number? And that's more like that.
So
would be
how many oranges did Susan and Jenny buy altogether?
Altogether,
right?
Then
and
that
that kind of makes it a multi-step problem. Too.
Sure, yes, it does, because now I'm just adding up 4 groups of 3.
That's right.
Well, thank you for joining us. We hope this Math Dive in 5 on tape diagrams or bar models has been helpful to you.
We'll see you back next time.
Bye.
Bye.